given chemical synapse, this one we are talking about the chemical synapse, means at any given chemical synapse only one type of the neurotransmitter is released, and therefore only one effect, either the excitatory or inhibitory, is possible. What does it mean? It means like a particular neuron will release only one type of the neurotransmitter at one particular synapse. If it is excitatory, it will always be excitatory. It can never be like at one time it is releasing the excitatory neurotransmitter, at the other time it will release the inhibitory. No, if it is excitatory, it will release the excitatory neurotransmitter. If it is inhibitory, it will release inhibitory. And this property is called as Dell's law. That is the first property of synapse. So sometimes they can ask you a large question with the property of the synapse, or sometimes they can ask you just a short answer question like what is Dell's law. The second one is one-way travel, that we all know, like in a chemical synapse, the impulse always travels from the presynaptic to the postsynaptic cell, and the neurotransmitter is only released from the presynaptic terminal. And this particular one-way travel thing, this is known as law of dynamic polarity, or Bell-Megendie or Megendie law. So this is the second property of travel. The third one is synaptic delay. This one we have also covered. Like, what is the synaptic delay? It is the time taken for the neurotransmitter to be released from the presynaptic membrane, diffuse across the synaptic cleft to reach the postsynaptic membrane and bind to the neuroreceptor there. So if we try to draw the diagram like in this way, suppose this is presynaptic neuron and there is postsynaptic neuron. If this was an electrical synapse, then there won't be any delay. That electrical impulse will travel like this way. But it is not an electrical synapse. We are talking about chemical synapse. So in the chemical synapse, that impulse traveled along this presynaptic neuron. Over here, it released the neurotransmitter, and those neurotransmitters, they get released over here. Then these neurotransmitters will travel along this synaptic cleft and get attached to the receptors, and that receptor, depending on which kind of neurotransmitter it is, they will generate EPSP or IPSP. And once that collective sum of EPSP or IPSP crosses the threshold level, then it will generate the impulse or action potential in the postsynaptic neuron. So the time taken by this entire process to happen, it will take some time. Now it will be very minimal, but still it will take some time, and that time is called as synaptic delay. Most of the times it is, in most of the cases, it is below 1 millisecond, and it's about 0.5 millisecond most of the times. Significance of the synaptic delay. The significance is when an impulse travels through a chain of the neuron, it is delayed at every synapse. Okay, just like say there are multiple synapses. Suppose we are taking the example of this one. This is one neuron, second order neuron, third order neuron, fourth order neuron, fifth order neuron. This is one example. And then we will take the second example. This is the experiment you will do in practical. I'll just give the example. Suppose this one. Okay, so this is the first neuron which we will stimulate, and this is the last neuron which is ending up on a particular muscle, and the effect is happening. Okay, this is stimulus. We can say this is the stimulus provides sensor, and this is effector, or effect is happening. Similarly, in this example, this is effector organ, and this is sensor where we are providing the stimulus. Okay. So if we take the example of the first one and the second one, in both the situations we are providing the stimulus of the same strength. Which one will take more time? Obviously the second example. Why? Because there are so many synapses. The number of synapses are more than the first example. 1, 2, 3, 4, 5, 6, 7, 8. But in the first there are only 4. So by providing the stimulus, and then we will simultaneously start recording the time taken from the application of the stimulus to the effect happening, like whenever the effect happens, then we will note down the duration. So that duration is called as time taken by a particular event to happen when we provide a stimulus. Okay, so that is called as reaction time or reflex time, depending on in which scenario we are talking. So just take it the example of reaction time, means we provided the stimulus, a reaction happen over here. So reaction time in this second example will be more as compared to the reaction time in the first example, because it's quite obvious the number of the synapses are more in the second example. So if we compare the auditory reaction time from the visual reaction time, that is the experiment we will do in the experimental physiology. Like we will set up one circuit where we will ask, like there will be two persons, and we will ask the subject not to look at the side. Like one person will create a sound like tap sound, and you will ask the second person to just press a button as soon as he or she hears the sound. That is one experiment. In the second experiment, you will ask the subject to tap the button as soon as he or she visualizing a lighting bulb. Like in one example, we will ask the subject to react to the visual stimuli whenever, like there are two persons doing this experiment, one person is creating the stimulus. In the first example, that first person will light the bulb. In the second example, that first person will create the sound, and the subject will respond in both the situations. In the first situation, as soon as that subject visualizes the bulb gets lightened up, then he will react, tap the button. And in the second example, as soon as the subject hears the sound, he will tap the button. So the stimulus is, like initial point is, in the visual stimuli is as soon as that person visualizes the lightened bulb, and then he will respond. So what is the connection? The connection is that visual stimulus will travel from the retina through the optic nerve. Ultimately from the optic nerve it will go to the occipital cortex. From the occipital cortex, that person is supposed to tap the button. It means with the hand. So the motor area in the cerebral hemisphere which corresponds to the hand, suppose that person happens to be the right arm. So in the right arm person, that motor homunculus in the cerebral hemisphere, it will get connected to the occipital cortex, and ultimately it will reach to the hand muscles. That is one pathway, visual one. The second one is hearing the sound. It means that stimulus will enter through the cochlea. From the cochlea, it will go to the auditory cortex, and to the auditory cortex, it will go via vestibulocochlear nerve, right? It will go via the vestibulocochlear nerve, and from the auditory cortex, it will reach to the motor homunculus and then respond. So what is the common pathway? Common pathway is whether it is reaching up to the auditory cortex or the occipital cortex. From the auditory and occipital cortex, it is ultimately going to the motor homunculus, and then it is the same pathway. So the difference between the reaction time in the visual reaction time or the auditory reaction time, it depends on how many synapses are there in the visual pathway or the auditory pathway. Number of the synapses are very much higher in the visual pathway as compared to the auditory. So when you will do this experiment or perform this experiment, you will see that the visual reaction time is always more as compared to the auditory reaction time, because the number of the synapses are more. Why there are number of synapses are more in the visual reaction time? Because within the retina there are so many photoreceptor cells, millions of the rod cells, cone cell, then they go to the ganglion cell, okay, and ultimately it goes to the optic nerve. So there are very higher number of the synapses as compared to the auditory pathway. So that is the clinical significance of synaptic delay. What was happening? This thing same, the release of neurotransmitter, diffusion of the neurotransmitter through synaptic cleft to the postsynaptic membrane. Now the action of neurotransmitter to bind with the receptor on the postsynaptic membrane, which causes opening of the ion channel, and diffusion of ion causing the changes in resting membrane potential by either generating the EPSP or IP. And spatial, this is one synaptic presynaptic element, this is second presynaptic element, and the postsynaptic was a single neuron. That is the difference. The two different presynaptic elements, 1 and 2, reaching a neuron simultaneously, and then it will add up. Like this example, this number 3 is postsynaptic neuron, number 1 and 2 are two different presynaptic elements, and temporal is the same neuron, same presynaptic neuron, and single postsynaptic neuron, and there are one impulse generated, then we provide the second impulse, then third impulse. So we can say the multiple impulses happening in one single presynaptic neuron. See what is happening in the temporal simulation diagrammatically. Temporal means timing. Single presynaptic element, multiple stimulation. So multiple stimulation is happening. First stimulus generated this much EPSP, second one this much. They get added up, summed up, and at one stage it reaches a certain level which crosses the threshold. This is the resting membrane potential, and this is threshold. So as soon as it crosses the threshold, by summing up of EPSP generated from multiple stimuli, it will generate action potential. That is a like this is the example of convergence. Like there is one impulse coming from the excitatory, the other one is coming from the inhibitory, but ultimately there is no change happening in the effector organ. It is the convergence. Or this is one more example of convergence. There are two different examples. One example is there is a single presynaptic neuron, but that single presynaptic neuron has multiple branches. So whatever the effect happens, it will get summed up. In the second example, postsynaptic neuron stays only one, whether A or B example. But presynaptic, there are 4 sources from 4 different neurons. So these 4 sources are either from 4 different neurons or from a single neuron. Ultimately, the resultant effect will be algebraically sum. That is called as the convergence. So convergence of signals on a single neuron. In the first example, convergence from a single source. In the second example, convergence from the multiple sources. And this is the example of ventral horn cell of spinal cord. Now, if there is convergence, there must be divergence. It means if one presynaptic neuron terminates on a postsynaptic neuron, it's not always necessary to end up only on one postsynaptic neuron. See, this is the presynaptic neuron, and there may be multiple postsynaptic neurons. So suppose the amplitude of the stimulus was 100, so this 100 will get divided between all 3. So we can say a single impulse is converted to a number of impulses going to a number of postsynaptic neurons, which may travel in the same track or into multiple tracks. What does it mean? It means we have taken the example of 3 neurons. Now these 3 neurons, they can ultimately go on one track, like say one track collectively, or they can go in different track, like these two, they go along in one track, and this one go along in a different track. So that's why they can move. What does it mean? It means they may travel in the same track or multiple tracks. So it causes magnification and amplification of an impulse. Means there is only one impulse and it magnified, get multiplied into so many impulses. So it gets magnified and amplified. Okay, like just take the example of this one, dam, electricity dam. Electricity generation, it happens from one source and then it like goes to so many cities, or we can say so many states, and ultimately it gets magnified and amplified. That is divergence, example of divergence. Okay, in this example, see, there is one presynaptic neuron, it gets divided into two branches. In the first order neuron there are two, then again they get diverged to two more, and ultimately 1, 2, 3, 6 and 8 nerve fibers from one neuron, presynaptic neuron gets, so it gets amplified. This is one example of going in same track, and this one there are two different tracks. 3 of them goes in track 1 and these 3 of them goes to track 2. This is the phenomenon of phase